Hello! In this lesson we're going to talk about derivatives of periodic functions. As you see, I have already plotted the function sine of x. As these functions are periodic in nature, we're going to study what happens for one period. Now on this graph of the function sine of x, represented by the blue curve, I'm going to try to determine the derivative in a graphical manner. As we know, the derivative of a function represents the slope of the tangent to the graph of that function. Therefore, let's take the tangent and analyze its values for one entire period. So for sine of x is going to be from 0 to 2 pi, and see what's happening. Let's see if we can identify any particular points. I'm going to animate this tangent at any point on the graph for one period. Pay attention to the values of the slope and see what they do. When x is 0, you see the value of the slope is 1. As we reach pi by 2, the value of the slope decreases to 0. It continues to decrease, and when x is pi, the slope is reaching minus 1. From this point on, the value of the slope, you see how it's increasing again, and when x is 3 pi by 2, goes through 0 again, continues to increase all the way to 2 pi, where the value of the slope is back to 1 again. Let's review in short what particular values we have identified. So when x is 0, our slope was 1. When x is pi by 2, the slope is 0. When x is pi, the slope has a value of minus 1. And when x is 2 pi again, at the end of the interval, the slope is 1. We identified that the derivative of sine of x is actually taking values between minus 1 and 1. Let's actually trace those values of the slope on the same graph for one period and see if we can identify the function that it represents. As you can see, it's a very well-known function, nothing else than the graph of cosine of x. Therefore, we can conclude that the derivative of sine of x is nothing else than cosine of x. In a similar manner, let's have a look at the function cosine of x and try to find what is its derivative. Now let's represent the tangent for this function as well, like we did in the previous instance. So once again, pay attention to the values of the slope and try to identify any particular values for this one as well. At 0, the value of the slope is 0 as well. At pi by 2, the value of the slope goes through minus 1 and then starts to increase, so that at pi the value of the slope is 0 again, continues to increase all the way to 3 pi by 2 when the slope becomes 1, which is its maximum, and then starts to decrease, so that at 2 pi the value of the slope is going to be 0 once again. And that's the end of the interval. Now that we identified, like before, several values, you see how we start at 0, we have a minimum of negative 1, we go through 0 again, a maximum of 1, and back to 0 again. So it's basically, again, a periodic function. Maybe it's gonna be helpful to trace this function once again, just like before, see how we can identify what type of function this represents. Okay, this looks very similar to the graph of a function sine of x, only that it starts by going in the negative direction instead of positive. So if I would plot the graph of negative sine of x, I would get exactly this graph. Therefore, we can conclude that the derivative of cosine of x is nothing other than negative of sine of x. And this is a very intuitive way to understand that the derivative of sine of x is cosine of x, and the derivative of cosine of x is minus sine of x. Thanks for watching.